Okay, ladies and gentlemen, let's go ahead and go again with a little bit more of this. Now, as you saw, Pascal's triangle is certainly a lot more efficient than dragging through multiple multiplications to try to get to the 6th power, 7th power, the 8th power. However, that's if we want the entire polynomial. In this case, let's say we just want to know, hey, what's the 5th term in x plus y to the 6th power. Now, the good news is we already know what x plus y to the 6th power is, and we know all its terms. So if I'm just looking for, say, the 4th term, 1, 2, 3, 4, this is going to be my answer I'm going for. But without having done that, can we do just that term with using just this value here? The answer is yes. Previously, we did arithmetic series, arithmetic sequence, geometric series, geometric sequence, and we had the recursive model. This Pascal's triangle is very much a recursive model because to get to the next term, you have to know the previous set. To know that set, you have to know the set before that. So that's recursive. You have to build it up. Multiplication, 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 multiplication. That's recursive. This is going to be the explicit formula. Now, the explicit formula, just like a to the n, is going to take us right to where we think we need to go. So in this case, we want to go right to the 4th term of x plus y to the 6th. Now, that formula is given any a plus b raised to a power. In our case, x plus y raised to the 6th power. I want, out of 6th, I want the 4th term. Now, I want the 4th term. This is going to be very important because although I can say 6c, but this is r. Now, r is not the 4th term. R is equal to whatever term number I'm looking for, in our case 4, minus 1. So r is going to equal 4 minus 1, which is 3. So it's going to be 6, choose 3. And we're going to then multiply that by whatever a is. Well, what's in a's slot here? Well, that's going to be x. Raised to the n minus r. Well, n minus r, n is 6 because that's the overall power, minus r that I found, which is 3. Y to the r, in this case b to the r, y to the r, which is r equals 3. So already we've gotten x cubed and y cubed, and that matches what we're going to need here in the end. However, what is this 6c3 stuff? Well, from Algebra 2 or Prob and Stats, this is actually combination. Most of the time when we see combination, we're talking about how do I choose a committee of 4 people, let's go, a committee of 3 people out of 10 people. A committee of 3 people out of 10 people. All right, and we're going to use combination because in this case, order does not matter. Otherwise, it would be a permutation. So NCR is defined by n factorial divided by n minus r factorial r factorial. Now, ladies and gentlemen, I don't remember what factorial is. Too bad. Factorial, if I have 4 factorial, that is 4 times 3 times 2 times 1. Okay, that's what we're working with now. It's just an example. In our case, we have 10, choose 3. And so we're going to have 10 factorial over 10 minus 3 factorial 3 times 3 factorial. Now, 10 factorial is 10, 9, 8, 7, 6, 5, 4, 1. Okay, in this case, on the bottom, we have 10 minus 3 factorial, which is 7. So 7, 6, 5, 4, 3, 2, 1, times 3 factorial, 3, 2, 1. So you have half and half. There you go. Now, because of fractions, all this is multiplication, all this is multiplication, there's a division in the middle. 7, 6, 5, 4, 3, 2, 1 here is going to cross out 7, 6, 5, 4, 3, 2, 1 here. That leaves us with 10 times 9 times 8 over 3 times 2 times 1. With that, we can continue to reduce. Those are going to reduce by 3. These are going to reduce by 2. And so I have 10 times 3, 10 times 3 times 4, which is 120. So there would be 120 ways to make a committee of 3 people out of 10 people. Now, let's go up here to the top and go back to what we were trying to accomplish to begin with. If I have 6 choose 3, that means I have 6 factorial over 6 minus 3 factorial, 3 factorial. So 6, 5, 4, 3, 2, 1 over, now that's going to be 3, 3, 2, 1, 3, 2, 1. Now 3, 2, 1 and 3, 2, 1 cancel out. 3 and 2 is 6. That cancels that, leaving me just 5 and 4, which is 20. And so 6 choose 3 is 20. X cubed, y cubed, and that's exactly what we had over here. That is using the binomial theorem to find any given value for any given component. Now, using all of that, let's go ahead and do another example. That example is, let's go with 2x plus 4y raised to the 12th power, but I want the 5th term. I want the 5th term. Well, if I want the 5th term, I'm going to say r equals 5 minus 1 is 4. I'm going to grab my formula right over here, and it's going to be 12 is n. So I have 12 choose 4 times, now a in this case is actually a group of things. It's 2x raised to the n minus r. Well, 12 minus 4 is to the 8th power times 4y, the quantity, raised to the 4th. Again, those two still equal 12. And so now I just need to figure this bit of it out. In this case, I have 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And on the bottom, I'm going to have 12 minus 4 factorial times 4 factorial. So let's see here. That's going to be 8, 7, 6, 5, 4, 3, 2, 1. And then 4, 3, 2, 1. With that, I can say 8 and back is gone. 8 and back is gone. 4 times 3 is 12. 4 times 3 is 12. I got a 2. Let's turn that into a 5. And so now I have 45. I have 11 times 5 times 9. And if I take 11 times 5 times 9, my coefficient is going to be 495 times 2x to the 8th times 4y to the 4th. Now you say, well, that's awful nice. That gets us right to the 5th term. I certainly don't want to multiply that out 11 times, and I certainly don't even want to do 12 levels of Pascal's triangle. So this works out nicely. If I wanted to truly finish, I could say 495 times 2 to the 8th, x to the 8th, times 4 to the 4th, times y to the 4th, and take all these numbers and throw this all in a calculator and get me one value for that coefficient that has x to the 8th, y to the 4th. Here's what I want you to do. Homework is 2x plus 4y to the 12th. I want the 7th term and the 11th term. Okay, there you go.